Hi everyone. Today was picture day. I hope you all took beautiful pictures. Today we are talking about equations, and I know you've learned about equations before, but we're going to take what might be a little bit different look at them. So take a second and read this paragraph. You don't need to listen to me reading it, but go ahead and read that paragraph and then unpause when you're ready to continue. So when we talk about a replacement set, we're talking about a set of specific numbers that they're giving us that we want to test and see which ones will create true statements, which ones will work in the equation. Okay, so let's walk through this example here. We have 3a plus 12 equals 39. And our replacement set is 6, 7, 8, 9, and 10. And so we're actually going to substitute, 6 in for a, and then 7 in for a, and then 8 in for a, and so on. Now, in our real lives, would we necessarily write every single equation down? Probably not. We would probably do some of this mentally or on our calculator. But I'm going to ask you to write it down in your notes just so that we make sure we know exactly what's happening. When it comes to doing your homework, will I expect to see every single sentence? Probably not. But so what we do is we substitute each of those members of the replacement set into the equation and we test it. And if we look at this first one, 3 times 6 is 18. 18 plus 12 gives us 30. Well, 30 does not equal 39, so that makes a false statement. When we substitute 7 in, we get a false statement. When we substitute 8 in, we get a false statement. But when we substitute 9 in, 3 times 9 is 27, plus 12 gives us 39. 39 does in fact equal 39, so we created a true statement. So then we continue on and we still test 10. And we always want to check every member of the replacement set because there might be more than one solution. And if you stop after the first one you get, then you won't find all of them, and that's a big problem. So you always want to check every member of the replacement set. But in this case, only one did work, so our solution set is 9. Okay, so go ahead and let's take a look at these next examples. You might want to pause for a minute and go ahead and write down your sentences and unpause when you're ready to continue. But if we look at number 1 here, 8 times 0 is 0. 0 minus 7 would give us negative 7, which does not equal 17. So this does not equal, and that would be false. 8 times 1 is 8. Well, 8 minus 7 gives us 1, which does not equal 17. So that's false. 8 times 2 is 16. 16 minus 7 is 9. That does not equal 17, so that one's false. 8 times 3 is 24. 24 minus 7 does equal 17. So that is the one that's true. And so our solution set would be 3 because that's the member. See how bad I am at making braces? That's the member of the replacement set that works. 3. Okay. In number 2 over here, we're going to do the same thing. If we simplify what's in parentheses first, this would be 3 times 0, which is 0, plus 1 is 1. 1 times 4 is 4, and that does not equal 28. Okay, I'm not going to say all of these out loud, but if you follow through, this next one will not equal because the right side is 16. But then in this one, 3 times 2 is 6, plus 1 is 7, times 4 is 28. This one works. And in the last one, it does not work, so that's false. So here, our solution set is 2, because that's the member of the replacement set that worked. All right? Now, when we also talk about equations, I'm going to hide some of this for a second. When we also talk about equations, they can have one solution, which is called a unique solution. They could have no solution, or they could have infinite solutions. So let's look at examples of all of those. In this first example, if we use our order of operations to go ahead and simplify that left-hand side, we would get this, and I could simplify it again. And I could also write that 16 divided by n as a fraction. I could say 4 plus 16 over n equals 8. And at this point, you might know how to go ahead and finish actually solving for n, but what I really want you to take a look at is stopping here and saying 4 plus what equals 8. Well, that means that this what part has to have a value of 4 because 4 plus 4 is 8. Well, within that, 16 divided by what is going to give me a value of 4, and it actually is 4. So n has to be 4 here in order for this statement to be true. So when you only have one value that will make the statement true, then it has a unique solution, and in this case, it's 4. On the back side here, I'm going to simplify, and I get 4n minus 14 equals 4n minus 9. And again, some of you might know how to solve these equations already, but we're not actually going to take the time to solve it. What I want you to recognize is that no matter what value of n I put in, the left side is never going to equal the right side. So there is no solution. And an example would be if, let's use 1 for n. Let's make it easy. If I put 1 in for n on both sides, this would give me 4 minus 14, which is negative 10. And over here, I would have 4 minus 9, which is negative 5. That's never going to equal, no matter what value of n I put in. And so this is an example that has no solution. Here's our next one. When I simplify using my order of operations, and I did a couple steps here at a time, so again, we're kind of past the point where I'm going to make you show me every single step every time. So I did a few steps at once. But ultimately, when I simplify it, I get 7 plus 3k equals 3k plus 7. Well, here's an example where no matter what value of n I substitute, the left side is always going to equal the right side. Therefore, my solution is any real number, which would be an infinite amount of solutions. And this has a special name. This is called an identity, since both sides of the equation are identical. I don't know if that's really the mathematical reason why it's called identity, but that's what helps me remember what an identity is, because both sides are identical. Okay, and so again, just for a quick example, let's use 2 for k this time. If I substitute 2 in on both sides, that would give me 7 plus 6. This gives me 6 plus 7, and both sides will equal 13. And so no matter what value I substitute in for n, I'm always going to get identical sides on the left and right hand side. And that will mean that I'll have all real numbers for a solution. All right, I want you to try these next 3 on your own. So pause it, try them on your own, and then when you're done, unpause it. And take a look at the solutions here. Okay, in number 1, you can take a look at my work, but that ends up being all real numbers, or an identity, or infinite solutions. Number 2 ends up being no solution. Number 3, we end up having a unique solution of 8. Because if we look here, 8 minus what equals 4? Well, this what part has to be 4. So 1/2 times what number will equal 4? And it's 1/2 of 8 will give me a value of 4. So 8 is my unique solution. Now, I'm going to give you an opportunity to earn a bonus point here. Take a look at this equation, and I want you to decide whether this is an identity, and then why it is or why it isn't. So now a question should pop up in your video, and you can answer that question there and submit it, and you could earn a bonus point. Have a great night. See you tomorrow.